Welcome everybody. In this video, we're going to take a look at the 8.5 notes. This is Mr. Gannon, and we're going to be focusing on graphing square and cube root functions. So like with any new functions we've talked about this year, we're always going to start by making a table of values so that we can kind of get an idea of what that shape looks like. Now, most of the time when we make a table of values, we're going to pick a couple of positive, a couple of negative numbers, and zero. This really is no different, but with square roots, we want to be a little bit selective of the values that we choose. So we're going to use 0, we're going to use -1, we're going to use +1. But for the other values, if we use 2, most people aren't going to know what the value of the square root of 2 is off the top of their head. So we want to try to choose a number that we know what the square root is, and those are our perfect squares. So after 1, the next perfect square would be 4, and we're going to go -4 here as well. So as we plug in those values to make our table, I'm going to start with 0. The square root of 0 is 0, so we can put a 0 there. Square root of 1 is 1, so we put a 1 there. Square root of 4 is 2. Now, when we look at the negative numbers, if we do the square root of -1, we end up with I. If we do the square root of -4, we're going to end up with 2i. So each of those represents a point on the graph, because when we make the table, we're basically creating coordinates that we can plot to graph the function. So as we plot these, we're going to plot the point 0, 0. We're going to plot the point 1, 1. We're going to plot the point 4, 2. But then if you try to plot the point -1i, I is an imaginary number, which means that point does not exist on the graph. And that's the same thing with -4, 2i. So our graph is going to look like this. And let me try to do a better job of actually going through the points. So it's a graph that's increasing at a decreasing rate. Now, some of the key elements of this function that we need to be aware of are there's an endpoint. Okay, so in this case, the endpoint is at 0, 0. When we talk about domain, domain are the x values. So we're going to look at this graph from left to right. Well, if we start over here at -infinity, there's nothing until we get to 0, but then it goes right forever to infinity. So we could write the domain as 0 to infinity in interval notation, or we could simply say that x is greater than or equal to 0. For the range, we're going to look at the graph from bottom up. So -infinity is down here, and we'll notice there's nothing till we get to 0, and then the graph does go up forever to infinity. So our range is going to be from 0 to infinity as well, if we're doing interval notation, or typically most people prefer set notation, where we'll go y is greater than or equal to 0. In behavior is going to talk about what do the left and right side of the graph do. Well, this function does not go to the left forever. So when we talk about in behavior, we're only going to focus on what's happening to the right. So we could say as x is approaching positive infinity, because that means to the right, y is also approaching positive infinity, because the right side of the graph is going up. Even though it goes up very slowly, it does always increase, and it will increase to infinity. So that gives us the basic shape as well as some of the key characteristics of a square root function. So when we graph, we want to understand that typically we're going to start at 0, 0. When we go right, when we go up 1, we have to go right 4 before we go up 2. Because the input is x, that's left to right. The output is y. So we don't go up 2 until we go right 4. So if you can remember those, it will help us apply the transformations that we've learned to graph any type of square root function. So as before, we have an HK version of this. So when we talk about the HK form, A is the number that's being multiplied in front, h is the value that's being added or subtracted to x, and k is the value that's being added or subtracted outside of the function. So just a quick review of those. If we're talking about a, if a is greater than 1, we say the graph is stretched by a. If a is a value that's greater than 0 but less than 1, we say that the function is compressed by a. For h, if it's x plus h, our graph is going to move to the left h. If it's x minus h, the graph is going to move to the right h. For our k value, when it's plus k, our graph's going to move up. And if it's minus k, our graph is going to move down. The only other thing that can happen is we could have that negative in front, which anytime there's a negative in front of our function, we have a reflection. And specifically, it's a vertical reflection in the x-axis. All right, so if we wanted to then basically take that parent function we graphed before and apply these transformations, we can use those to graph any of these functions. My recommendation would be to pause the video, try each one of these on your own, and then kind of continue with the video to see how you did. So on number 1, the only transformation we have is this 2. So we could say that the function is going to be stretched by 2, which means there's no left, right, up, or down movement. So just like the parent function, we're going to start at 0, 0. Normally the function goes right 1, up 1. Well, the stretch always affects that vertical movement. So we're going to go right 1, up 1 times 2, which is 2. Normally from the endpoint we go right 4, up 2. Well, this again is telling us to go 2 times 2 up. So 1, 2, 3, 4. And the shape is going to maintain that same general shape, but it is stretched. Our domain will be x is greater than or equal to 0, because we're still starting at 0 going to infinity. Our range will be y is greater than or equal to 0, again because we're starting at 0, we're going to infinity. And then for the end behavior, as x is approaching infinity, y is approaching infinity, because as the graph goes right, it also goes up. All right, and that would be the graph for y equals 2 radical x. All right, if we take a look at number 2, now we have a negative 2, or we're subtracting 2 inside the radical. So x minus 2 is telling us to move to the right 2. So from the initial endpoint of 0, 0, we're going to go right 2, and that becomes our endpoint. Follow the pattern of right 1, up 1, right 4, up 2, and that's how we get the additional points and the shape of our graph. When we look for the domain this time, all right, when we read the graph from left to right, we don't start at 0, we start at 2. So our domain is going to start at 2 and go to infinity. So we could say that x is greater than or equal to positive 2. In terms of the range, from bottom up, we are still going to start at 0 to infinity, so y is greater than or equal to 0. And then again, in behavior, our graph only goes to the right. So as x is approaching infinity, y is approaching infinity. As the graph goes right, it is also going up. All right, guys, hopefully you're seeing how we're able to take things that we've learned in previous lessons with graphing and just apply it to this shape. Now for number 3, this time we've got a negative in front. So a negative in front is always going to cause a reflection. The plus 3 is now outside of the radical, so that's going to move the graph up 3. So what this will look like is, starting at 0, 0, we're going to move up 3. That becomes the endpoint. Normally, the parent function goes right 1, up 1. Well, there's one thing that's going to affect that, and that's the reflection. So instead of us going right 1, up 1, it's reflected, and we're going to go right 1, down 1. right 4, down 2. Now our graph is curving down as we move to the right. So looking at the domain, left to right, we start at 0, we go to infinity. So x has to be greater than or equal to 0. What's different now, though, is our range. So if we look at the graph from the bottom up, well, this graph is going to go down forever, which means we start at negative infinity and we end at this 3. So our range, y, is less than or equal to 3 with that reflection. The other thing that's going to affect that reflection, or that's going to be affected by the reflection, is the end behavior. Because now, as x is approaching infinity, which is to the right, y is approaching negative infinity, because as we move right, our graph goes down. And moving on to number 4, all right, we've got this 1/5 in front, so that's going to be a compression. So we are compressed by 1/5. We have x plus 3 inside the radical, which is left 3. And we have minus 4 outside, which is down 4. So now when we go to graph, from the point 0, 0, we're going to move left 3, down 4. And instead of moving right 1, up 1, the compression is going to move us right 1, up a 5th. Now that's going to be pretty tough to graph, all right, because a 5th is not, especially on this graph here. If we go right 4, normally we go up 2. Now we're going up 2/5. Well, that's not even a half. So the shape's going to maintain the same idea, all right, but it's going to be very flat due to that compression. So for our domain, as we look at the graph from left to right, we're starting at negative 3. We are going to infinity. So x is greater than or equal to negative 3. For the range, we are starting at negative 4. And we are going to infinity. So y is greater than or equal to negative 4. And then in behavior, as x is approaching infinity, y is approaching infinity. As the graph goes to the right, it is going up. Now, while it grows very slow, it does go towards infinity. All right, so that is how we can take, the square root function, the parent function, and apply the transformations to graph. So you're always going to have an endpoint, and for us, our graphs for square root functions will always go to the right. There are transformations that would cause it to go the other direction, but we will not be doing that this year. All right, we have one more function to look at. So we're not going to graph any other roots besides square roots and cube roots, but cube roots graphs are going to look different than square roots. So how this is going to work is same idea. We're going to start with the table. So we want to make that table of values. We're going to have x and y. All right, we're going to use -1, 0, and 1, just like we did before. But we have to, again, be selective on the other values that we choose. When it's a cube root, again, if we chose 2, not many people are going to know what the cube root of 2 is off the top of their head. So we want to pick a number that we do know the cube root of, and those are the perfect cubes. Well, the first perfect cube after 1 is 8. So we're going to choose 8 and -8. Whoops, not infinity. 8 and -8 to create our table. If we plug in 0, cube root of 0 is 0. If we plug in 1, cube root of 1 is 1. And if we plug in 8, cube root of 8 is 2. Now this is where things, you really got to make sure you're paying attention when you're working with radicals. If it's a -1 and I'm taking the cube root of it, the cube root of -1 is -1. Because when we multiply -1 by -1, we get -1. And the cube root of -8 is -2. Those are not imaginary numbers. So that's going to mean the graph is going to look different. So if we started plotting these points, well, 0, 0 is here. 1, 1 is still going to be right 1, up 1. We're going to go right 8 before we go up 2. So 1, 2, 3, 4, 5, 6, 7, 8 would be off here. So we're going right 8 before we go up 2. If we look at that right side of the graph, it looks similar to our square root function. Okay, it is stretched out horizontally a little bit, but it does still contain the same point 0, 0, and 1, 1. So that's good to know. But now we have these other coordinates that we can plot, -1, -1. So from that center 0, 0, we're going to go left 1, down 1. And then -8, 2 is left 8. 1, 2, 3, 4, 5, 6, 7, 8, down 2 here. So our graph is now going to curve and go down to the left as well. So this is generally has kind of an S-shaped curve. The key points, the center is that point right there. So we are still starting essentially at 0, 0. But what really becomes different now is that we have both positive and negative values for x that we can apply. So our graph is going left forever, so -infinity, and right forever, so positive infinity. So the domain is -infinity to positive infinity, which can be written as all real numbers. And for the range, our y values, well, it's going left and down, so it's going from -infinity. The right side goes up, which is positive infinity. So the range becomes -infinity to positive infinity, which again can be written as all real numbers. In behavior is talking about left side and right side. Well, now we do have a left side and a right side. So if we're going to write the in behavior, we could say as x is approaching -infinity, which means the left, y is approaching -infinity. Left side is going down. As x is approaching positive infinity, y is approaching positive infinity. Right side goes up. If you wanted to abbreviate this and write it as a single statement, that's fine. You would write it as x is approaching plus or minus infinity, y is approaching. Now, what you would have to make sure happens if you're going to write it like this is that the top sign corresponds to positive infinity, which in this example is positive. The bottom sign corresponds with negative infinity, which is negative. So those signs would have to match here. So positive infinity goes to positive, negative goes to negative. So we would put plus minus here. That's just a way to, simplify it down to where you can write it as a single statement versus two individual. All right, let's go ahead and take a look at what those transformations look like, and that should be able to get you going on the homework. So for each radical function, all right, HK form is going to look like this. Notice the only difference is that index right there. That's telling us that it's going to have more of that S shape, which goes right and up, left and down, versus only going to the right when it's a square root. So here, all right, there's that cube root. We start to identify transformations. The x plus 2 is going to move us to the left 2. The minus 3 is going to move us down 3. So for us to graph this, from the center, or from the origin, 0, 0, we're going to go left 2, down 3. That point is now going to be the center. We don't have any stretch or compression. So right 1, up 1, right 8, 1, 2, 3, 4, 5, 6, 7, 8 is up 2. But we also have to go left 1, down 1. So this graph is going to curve up as we go to the right, and it's going to come down as we go to the left. One of the nice things about the cube root functions is domain and range is pretty simple. It's going to always be all real numbers for both. The in behavior, as x is approaching plus minus infinity, y is approaching. Well, our top sign is corresponding to the right. The right side is going up, which is positive infinity. Left side is going down, which is negative infinity. And that takes care of in behavior. All right. for number 6, all right, again, if you guys are not pausing the video and trying this on your own, I would definitely recommend that you do that. So if we're taking a look at number 6, this time we have a 2 in front. That's going to cause a stretch. So we have a stretch by 2, and this plus 4 is going to move the graph up 4. So to graph this, starting from 0, 0, we're going to move up 4, put a point. There's, again, no reflection, so we're going to go right and up. Normally it's right 1, up 1. The stretch tells us to go right 1, up 2. Right 8 would tell us to go up 2, but if we multiply that by 2, we go up 4. So the right side of the graph is going to look like this, and left 1 is going to be down 2, left 8 is going to be down 4, and the graph's going to look like that. All right, this graph goes left and right forever, so we have domain of all real numbers. The graph goes down and up forever, so all real numbers. And in behavior, as x is approaching, plus or minus infinity. All right, the top is the right, so the right side's going up, so it's going to be plus minus infinity as well. I mean, to me, guys, we already know the transformations. Once you really understand the parent function and the shape, this stuff can be done pretty quickly. All right, so we got a couple more examples to get through. So now if we take a look at number 7, we got that cube root again. Now we have a negative in front. So the negative is going to cause a reflection. And then x plus 5 is going to move us to the left 5. So for us to graph this, we're going to start at 0, 0, go left 5. That's our center. Normally it's right 1, up 1. The reflection tells us to go right 1, down 1. And then we're going to go right 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 2. And then left 1 is going to go up 1 due to the reflection, and that side looks like that. Again, even though it's reflected, the graph still goes left and right forever. So we have a domain of all real numbers. It goes up and down forever. The range is all real numbers. But there is going to be a difference in the in behavior. So this time, as x is approaching plus or minus infinity, all right, the top sign represents the right side of our graph. Well, this time the right side is going down. So y is going to approach negative infinity to the right. The left side is the bottom sign. It's going up, so positive goes here. So really you can, kind of think about this as if you're always writing as x approaches plus or minus infinity, if there's no reflection, y is going to approach plus or minus infinity. If there is a reflection, then those signs just flip. All right. Let's see, one more example graphing, and then we got a couple other questions that we'll get to. So for number 8, this is written slightly different. And a lot of times people will look at this and they're not kind of being careful, and they see this 2 and they want to say it's stretched by 2. This 2, though, is not being multiplied. This 2, it's being added. So whether we add it in front or we add it over here, it's going to have the same effect. All right, so this 2 is actually going to move the graph up 2. The 1/2 in front is going to be our compression, because that's what's being multiplied by the radical. And then the -3 is going to move us to the right 3. So be careful with that. From 0, 0, we're going to move right 3, up 2. There's no reflection, so we're going to move right 1, up 1/2 due to the compression. We can't really go right 8, so don't worry about that. Just sketch that. When we go left 1, we're going to go down 1/2. When we go left 8, 1, 2, 3, 4, 5, 6, 7, 8. Normally we go down 2. Half of 2 is 1, so we go down 1. And again, you're just going to do your best to kind of draw that flat curve. For domain, we're going left and right forever, so that's all real numbers. Range going going up and down forever, so all real numbers. And then our in behavior, as x is approaching plus or minus infinity, y is approaching. Well, again, top sign is the right, it's going up, plus, minus, infinity. Guys, rewatch the video as you need to be able to understand how to graph these. A couple more examples, and then that'll be it for these notes. So example 9 wants you to translate the graph so that it has a range where y is greater than or equal to 3. Well, you just got to think about what's going on. Normally, when you have that square root graph, all right, we start at 0, 0, right 1 goes up 1, all right, and the graph goes like this. In the range of this function, the range y is greater than or equal to 0. Well, if we want the range to be y is greater than or equal to 3, then that means our graph needs to start up 3 and go like this. So we want to think about, what do we need to do to this equation to make the graph go up 3? Well, that's just adding 3 outside of the radical. Okay. So it's just thinking about what's going to cause that range to change. And with, square root functions, it's moving the graph up or down, which happens through adding outside the radical. All right, moving on, example 10. It says, which of the following statements about this graph is correct? All right, so if we take a look, all of the answer choices talk about increasing versus decreasing. So when we're looking at a graph and deciding, is it increasing or decreasing, we're reading it left to right. So first thing I would do is look at this graph as we go from left to right. So starting at the left, what's the graph doing? Well, it's going up, which means it's increasing. That's going to allow us to eliminate C and D. So then we can focus on A and B and decide which one is correct. So A is saying that the function f of x is increasing over the interval from negative infinity to infinity. Well, negative infinity is over here, and the graph doesn't even exist. And it doesn't exist until we get to 2. So this is incorrect. B says that f of x is increasing over the interval from 2 to infinity. Well, again, it starts at 2, it goes up forever to the right. That's our answer. All right, hope you guys found this video helpful. If you have any questions, I first start trying to rewatch the examples, and then if you're not, just message me with any questions.